What's up everybody, Rudy here. Wanted to do a video on how I went about achieving my apex seal to rotor groove clearance. So basically comparing the thickness of the seal and getting a clearance between it and the width of the rotor groove. Hopefully you could see that there. Essentially I wanted to go over how I went about achieving that with this granite block here. I use 800 grit sandpaper and also kind of consolidate the information I was able to find with regards to this clearance. So I guess starting off, Mazda OEM specification for this clearance is going to be 2 to 4 thousandths of an inch, and with a maximum allowable tolerance of 6 thousandths. So that's, sounds pretty fair, pretty reasonable. 2 to 4 thousandths is what you want to kind of look for. In my case, I went for about 2 thousandths clearance, and I'll go into explaining how I got to those two type of values there. The only other people or company that said otherwise really is going to be Goopy Performance. They spec theirs out to a 1.5 thousandths groove to apex seal clearance. I'm not sure why they do that, but they do kind of dictate that that's the case for turbocharged forced induction and naturally aspirated. So there you go, 1.5 thousandths for Goopy, 2 to 4 thousandths for pretty much any other seal, I'm assuming. This is an Atkins seal. I was not able to find specific information for their seal, but just, going off Mazda OEM, it's pretty safe to say that's what we're gonna run. So how I went about checking that clearance is by grabbing the apex seal, specific to that's going to be tied to that slot or that groove. In this case, I have my number 3, this is the rear rotor in my engine, the number 3 apex seal, and I grabbed the small spring, not the big one, just the small one is a little bit easier to kind of manage and work with for this instance. And so I drop this in here, and actually you might want to drop this in with the side that's going to be facing outwards. In this case, this is a rear rotor, rear stationary gear. This is the rear of the engine. When I assemble this engine, the corner seal is going to be facing towards us. So drop that in, kind of center it up. And then I'm going to grab the 2.5 thousandths feeler gauge, and I could feel a good amount of resistance here. So it might be tighter than 2.5 thousandths, but it fits in there. It drags with very kind of minimal resistance. If I put the 2 thousandths feeler gauge in here, it's still drags, but it's very, very, very light. I would say that's somewhere in between the two, maybe even 2 thousandths, depending on who you talk to. And if we put it on the other side of the seal, this feels even looser, I would say. So that might be an effect of the way that the rotor kind of deforms over the years, depending on the combustion shenanigans going on in here. And so then just to mess around, I'm going to fit the 1.5 thousandths feeler gauge, and that just kind of slips right in. With this side, it's just free floating really. This side, it does grab just a smidge, mostly in the center. So I'm going to call this clearance to about 2 thousandths, 2.5 thousandths clearance. And so I'll go over the way I achieved that, and that was by, again, we set this aside. That was by using a 800 grit sandpaper on a flat granite block. So the way I did it, not to kind of, there's a million ways you could skin a cat, so to speak, but the way I did it was I placed the apex seal kind of diagonally and then ran the seal lengthwise, trying to apply even pressure across the seal. So I would do this maybe 5 to 10 times depending on how much material I would want to take off. Then I would kind of turn it the other way diagonally, do that again, five times or so, flip it over, do that, same motion, turn it to the other direction, do that again, and I would creep up on that clearance slowly while at the same time leaving almost like a mirror finish. Really, it really leaves a very kind of smooth finish on the seal. You could use like a 600, maybe even a 400 grit sandpaper, but for one, you might come up on that clearance way too fast. You might overshoot your clearance, which is probably not a bad problem, but if we're trying to go for as best we can as far as that clearance that we're trying to achieve, you're better off going with a 800 grit or somewhere around that. So yeah, run it back and forth, check it, run it back and forth, keep flipping it, keep rotating it and doing all that, and you'll achieve the clearance that you want to achieve. Once that's done, or actually throughout that whole process, I'll sometimes intermittently check to see where my thickness is, and in this case, and really in most cases for all 6 of the apex seals of my engine, I ended up just a hair under 76 thousandths. So hopefully you could kind of make that out. And this is not, I don't know how accurate this caliper is. I mean, it's a Harbor Freight caliper, but the thing we're trying to achieve here obviously is going to be repeatability. And these feeler gauges are super common and pretty accurate. So this is really where you're going to base your kind of feel or measurement off of. This is just kind of for peace of mind and also to keep reference of how much material you've taken off. Once you do that, once you have this, portion of the seal clearanced, I'll go to the corner seal piece or the triangle piece, and I'll check that out. And in my case, I ended up leaving it just a hair over 76 thousandths. So whereas this was just under 76, so you could call that like 75.8 maybe thousandths of an inch. This was maybe 76.0, 76.1. So just kind of for reference, each engine might be a little bit different. These are all kind of spec'd out per your build. This is where you're getting into the kind of art of building an engine. But yeah, that pretty much covers that. I have seen a lot of people kind of run a file through here to get that clearance. There's a file, I think Extreme Rotaries makes a specific file for 2mm and 3mm thick rotor grooves, which is fine. I guess you could do that. In my opinion, I think we're better off kind of working the apex seal to the proper clearance rather than changing that rotor groove clearance, because if you ever need to go back to a tighter tolerance for whatever reason, if you get new seals that are a bit kind of thinner, that's you're not going to be able to necessarily add material to that. You could easily just buy new seals and rework this process as you see fit. So yeah, that pretty much covers it. Again, I just wanted to consolidate this information and also give people kind of a quick overview of how I went about achieving that clearance. In the past, I wouldn't even think twice about kind of speccing this out. I would just kind of drop it in if it felt nice, if it felt loose and cool, we're good. But it might be worth checking and running your feeler gauges through there just to make sure that you're not running too tight. Again, Mazda calls for 0.02 of an inch minimum, quote unquote. Goopy calls for 1.5 thousandths. So, kind of have fun, build your engines how you want to, make them last, make them make power. And the last thing I wanted to go over was apex seal warpage. These seals I've been running in my engine for a couple of years, but one thing you always want to also check is for the warpage. So the Mazda factory manual calls that, actually let me grab that real quick. The Mazda manual says that you want to butt up 2 of these apex seals and then check for any gap or clearance between the 2 seals. And I think maximum allowable, maximum kind of gap in here is going to be 2.5 thousandths. So we run this through here. I don't know if it's because it's probably because I'm not holding this right, to be honest. Let's see, so if I put some tension on here, which obviously if I put tension here, I'm not strong enough to where I'm flexing these in and kind of closing any gap that might exist there. So I'm going to use a 2.5 thousandths feeler, and it's just not going in at all. Reason for that is, again, I love these granite blocks. What I did was, or what I like to do, is check this kind of clearance edge against the flat surface, put a 1.5 thousandths clearance feeler gauge in there, and see if it'll fit. In my case, it doesn't. And in one of the workshop repair manuals from Mazda, they do kind of reference this measurement, where if you set it up against a flat surface, you should not be able to fit a 1 thousandths and 2/10 of an inch, so 0.0012 inch clearance should not be there. So in this case, 1.5 is the best I got, and it's perfectly flat. Part of the reason, the reason for that is I actually did run this through here a couple of times just to make it all good and smooth. And you might want to check that with new seals, although for the most part I think you'll be fine without necessarily doing that. So yeah, I think that pretty much covers it. Again, just wanted to consolidate some of the information I saw out there with regards to the apex seal to rotor groove clearance, the warpage, which is not a common issue, but the clearance I think is something that a lot of people kind of overlook. I mean, I used to, and I built a couple of engines, and did I actually run this gauge in there and think, oh yeah, it's good enough? Probably. Did I go through and kind of smooth things out and make sure I have a proper equal tolerance between all 6 or however many apex seal grooves? I did not do that. I just kind of went by feel. But if you're going to be building an engine, you're better off just taking your time, making sure they're all going to be within spec, within a specification that you want. And I ended up going the route of using 800 grit sandpaper on a flat granite block to achieve that goal. So yeah, that pretty much does it. If you happen to have any questions, I guess drop them in the comments. If you want to see a video like this about any other aspect of the engine, let me know. I mean, I'm not working and building on these engines all the time. I just have my personal RX-7 that I'm working on, but I have been kind of diving deep more and more throughout the last years of ownership of my car for this. And this is something new to me that I didn't find a whole lot of information on out there. So yeah, drop a comment if you have any questions. Subscribe to our channel. Check out our website. See you next time.